In this video, we'll look at energy diagrams for organic reactions. Remember that we saw energy diagrams when we learned about Newman projections. And with Newman projections, the energy diagram was a way to indicate the energy of the molecule as we rotate around a bond. Here, for a reaction, an energy diagram is a way to indicate the energy of a whole reaction system as the reaction proceeds from starting materials to products. And we'll use the reaction of ethylene with HBr as our example. This is an addition reaction. Two reactants come together to form one product. And in this reaction, there are two steps. In the first step, the pi bond acts as a nucleophile that attacks the proton of HBr, and then the HBr bond breaks. And this doesn't immediately form the reaction products. Instead, it forms an intermediate, the structure shown in brackets, where we have a carbocation and a bromide anion. A reaction intermediate is less stable than the product or the starting materials and only exists transiently during the reaction. From this intermediate, there's a second step where the bromide attacks the carbocation to form the new carbon-bromine bond. These two reaction steps combined make up the overall reaction. Now let's look at what the energy diagram will look like for this reaction. The x-axis of the energy diagram is the reaction coordinate, or reaction progress. So the left side is the beginning of the reaction, and the right side is the end of the reaction. The y-axis is the energy of the system. First, I'll just indicate the reactants or starting materials and the products. And there's an intermediate in this reaction, so I'll indicate the energy of that intermediate here. And each of the two reaction steps has a transition state associated with it, and I'll indicate that transition state energy with Ts. The reaction begins with the energy of the reactants, the starting materials, and the reactants come together, they collide to begin the reaction. And in the beginning of this step, the electron clouds of the two reactants repel one another, increasing the energy of the system. The reactants continue coming together until that transition state is reached. And the transition state is the highest energy structure. And in the first transition state, the carbon-carbon pi bond and HBr sigma bonds are partially broken. The new carbon-hydrogen bond is partially formed. The bonds then continue to break and form to generate the product, or in the case of step 1, to generate the intermediate. The second step occurs just like the first, with its own transition state and its own energy to form the products. The overall change in energy during the reaction, the difference in energy between the starting materials and the products, is delta G. And this value tells us if the reaction is favorable or unfavorable. A negative value is where the products are lower in energy than the starting materials, and this indicates a favorable reaction. The difference in energy between the starting materials and the transition state is delta G double dagger. This is the activation energy, and this value tells us how fast a reaction will proceed. A smaller activation barrier will lead to a faster reaction.